Good afternoon, everybody. It's a pleasure to talk to you today about our fantastic postgraduate programme at Informatics. We are one of the largest schools in the world, and we believe we're the largest one in Europe, with over 160 academics researching and teaching in a variety of disciplines around AI, computer science, but also related disciplines such as computational cognitive science, robotics, quantum, cybersecurity. The list really does go on. And we are consistently ranked in the top 30 worldwide. And if you're interested in coming to the UK, you'll be keen to know that we are ranked 4th in the UK this year. So we really are world-leading institute. We are also one of the oldest institutes to be teaching and researching in artificial intelligence. This started 60 years ago, and we recently celebrated our 60-year anniversary. We think we are one of the oldest in the world, and this is what it looked like back in the day. That was our graduating class, 1974. And this is what it looks like today, much more diverse. This is what the computers and the robots looked like back then. But today we are using cutting-edge equipment and to facilitate our research, such as the NASA Valkyrie, and we're the only place in Europe that has one of these NASA robots. So that's just an example of the fantastic research that we are doing here at Informatics. So, as I mentioned, we are one of the largest, so we have about 450 staff. That includes about 160 academics and the same number of research staff. We have about just under 2,000 students at any time, so a cohort that you would be joining is about 350 MSc students. And you can really see the ecosystem that you'll be joining, as well as your MSc cohort. We also have PhD students, around over 500 PhD students. We're very proud of our equality, diversity and inclusion, and for that we did win a Athena Forum Silver Award that was given to us last year. We're an ecosystem for innovation and entrepreneurships, and we have a record number of startup and spin-outs coming out of the school each year. And our lecturers are world-class in terms of quality of teaching, as reflected by our nominations for teaching awards that the students give us. And our staff have many accolades, including, nonetheless, a Nobel Prize. It was Jeff Hinton, who is an alumnus of ours, was awarded the Nobel Prize last year for his work on AI, which all started here at Informatics. So why Edinburgh? So Professor Iain Murray is going to talk about the wide range of exciting cutting-edge courses that will be available to you. And because of this breadth of courses, you are able to tailor your studies to your interests and your career aspirations. We have dedicated support for careers as well as commercialization and entrepreneurship. So if you're interested in creating your own company based on your work that you do in your master's, we can help facilitate that through various initiatives and training. Our graduates are highly sought after by industry, and this is because our teaching is research-led and our research is world-leading. So there's an exercise called REF that we do in the UK, and the last REF in 2021, we produced more high-quality research outputs of papers, for example, than any other university in the UK for our discipline. So we really are recognised leaders in the field, and we do attract the brightest and best from all over the world. So it is very competitive to come to Edinburgh. That's all for me. Thank you very much. I'll now hand over to Iain, who's going to give you some more details.
Thank you, Helen. So welcome everyone. What I'm going to do is spend about 20 minutes talking about an overview of the programme and more detail of what it would be like to come here. So as you can see in this opening slide, Edinburgh is a beautiful place. I moved here in 2010, and I personally moved here as a machine learning researcher because this enormous school has experts in every area. So for me, it was personally really useful that there were experts in speech that helped me publish in speech, which I wouldn't have been able to do otherwise. And we also have experts in systems that can make the big machines go that we need to do the AI that I'm personally interested in. So you'll have your own interests, and you have applied for one of our master's programs, and we have several. So some of these have quite constrained course selections. So the financial computing degree, design informatics, cybersecurity, these have relatively more guided course paths where they're specialist subjects and you will follow those. Some of the degrees like artificial intelligence and data science and computer science have much more free course selections. We have very broad research interests in the school, and to some extent you can piece those together within these degrees. So I'll explain how that works. Just to mention, if you're interested in high performance computing with data science, which you might have seen in the prospectus, although that's officially part of the School of Informatics, it's taught separately by EPCC. So if you're interested in that degree, we're not covering it in this session, but we'll give you contact details at the end where you can ask questions about that. So if you're taking one of these degrees, you'd be wondering, what are the courses I'd be taking, because they're so broad. So what we've done in our advice for students is we have identified specialist areas or portfolios of courses that reflect the research interests in the school. So these vary from the quite theoretical, like formal methods and quantum informatics, very specialized, to more traditional mainstream parts of computer science and artificial intelligence. So if you were taking one of our broad degrees, you would presumably be applying with in mind that you would like to specialize in some of these areas, and we have multiple courses within those. I'll give you an overview of the year before I say a bit more about courses. So the Edinburgh year is split into 3 parts. There's a first semester, which starts in September and runs until December. Second semester, which we're currently in, which runs in the spring. Both of those semesters are roughly 10 weeks long. You are around for longer after those 10 weeks to take exams and do revision. And then the summer period, which runs between June and late August, is where only master's students are around. You're doing research. So you do taught courses in the first 2 semesters, and then you specialize in a research project in this third part of the year. So those first 2 chunks, the first 2 semesters, are where the taught courses are, and you take what in our system are 60 credits of courses. That's often 3 or 4 different courses. If you're taking one of these broad degrees, there's a lot of choice. The main thing you have to do is to do with research skills. Most of our degrees, you have to do a literature review in the first semester to get familiar with the field. And in the second semester, you start preparing for the research you're going to do in summer. But then what your other courses are, your other 3 or 4 courses, depend on your interests and what fits together for where you want to be at the end. What the courses look like depends on what you're doing, because some of our courses are much more applied and application focused, and you might spend more time in a lab programming. Other courses are much more theoretical, and it might be much more focused on lectures and self-study towards an exam. So we don't have one fixed recipe for what a course looks like, but roughly each course will have 2 or 3 lectures a week. Often some other activity like a small group tutorial or a lab session where you work on something and discuss with tutors. So each course will have usually between 2 to 5 sessions during the week where you would meet with people on that course. Because we have this big free choice, there is responsibility for the students picking those courses to make sure that they have the background to do the course. So we're very proud that all of our students come from many different backgrounds into our program. That's both the country that they've come from, but also the degree they've taken. So many of our students have done some form of computer science or informatics before, but others have other degrees like physics or engineering or sometimes linguistics if you're going into cognitive science, many different areas. I myself have a physics undergrad degree and I moved into artificial intelligence from physics. So it absolutely works. There are these varied routes, but as a result of those different routes, people come in with different backgrounds. So we do assume that you have some level of maths and some level of programming to take a lot of our courses. And although we have partners in other schools that teach some programming classes that some of our students use to refine their programming, we're really assuming that programming wouldn't be an issue for you and you'd be able to program in the language that's necessary, which is often Python, but not always, for the courses you're doing. So particularly for people interested in cognitive science and coming in from the sort of edges of computer science into our programs, it's really advisable to brush up on your programming. You should have done some programming to get an offer, but also do some practice over the summer. So this large selection of choices can be a bit overwhelming. We have advisors that will help you pick your course selection. You would do that over the summer so that when you arrive, you've got a good idea of what you would be doing. But we know that this choice can be difficult and you might need to change your mind. So starting from now, you could look at the courses that are likely to be on offer. There's a link on this slide, and perhaps at some point we'll put a link in the chat that will show you the courses that we're running this year. They'll be much the same next year, but because we have this large selection at the cutting edge, it does change slightly every year. We don't guarantee what course we'll be running. But once we've got the list of courses that are running next year, we'll invite people who've accepted offers to pick their courses. And then once you arrive, if you thought, oh no, I've made a mistake, it is possible to change that selection. So you can go to the first week of lectures, meet the lecturer, see what's going on, and some students change one or two of their course choices at that point. The other part of the year I mentioned was the dissertation in that third chunk of the year. That is a serious piece of independent work. You write a substantial 40-page report that describes what you did. And this is really useful for talking to employers, going into any sort of research afterwards, showing that you've got these sort of independent skills and you can get deep into some area. To give you a flavor of what it's like, our current master students are currently choosing their project because they're going to start researching what they're going to do now. And our internal system currently has 317 different projects that staff have proposed, so different research areas that students could pick. Some students have proposed their own topics, so 46 students have suggested projects that they would like to do. From experience, probably about half of those students will actually end up doing those projects and find a member of staff to supervise it, and the other half will decide actually to do one of the projects that we've proposed. And then roughly 40 of the projects on offer have some sort of industry support. There's a link with a company, and often someone in that company is involved in the supervision as well. So there's this large selection of projects to choose from. Sometimes we have multiple students working in the same space. So one of these projects that's proposed, multiple students could do the project with the same title, but they're still working independently. You don't have to rely on other students succeeding for your project to work. You have a group that you can meet with and chat about what you're doing, and you can share things if you want, but you're going to find your own direction and do your own project no matter what. So to give you some flavor of what these projects are, I went through the list of projects from last year that were popular, and I just pulled out some from different areas. So these are titles of dissertations that master's students here have done. What sticks out to me when I look at this list is I don't know what some of these things mean. So I don't know exactly what quantum circuit knitting is, but there are people in our department who do. And I think it's great that there are master's students who know far more about this area than I do. It shows that these students are getting to the cutting edge in some area. So these won't be the projects that are available this year or next year. They change every year. But they show that you can get into something really interesting, cutting edge. And whatever it is, that means that you've got something you can talk with employers about. So employers don't care whether you have got particular expertise in quantum circuit knitting or searching for voices in languages that can't be written down. Occasionally, someone might be looking for that particular experience. But the main thing you get from doing a dissertation is that you've got a unique experience that you can talk about that demonstrates you can get on something on top of something that's new. And we do have a good reputation with employers for having strong graduates that come out with those sorts of skills. Most of our MSc graduates go straight into employment, and they get employed by a wide variety of sort of good companies. So on the slide, there's listed some of the recent employers, and these are the ones we can list because multiple students went to them. And so they're the big companies that you've heard of. So the big finance companies, the big tech companies. But really, there's a very long tail of companies that students end up going to, because across industry, everyone cares about informatics. Everyone needs experts in all areas of computing. And so you shouldn't sort of focus just on these individual companies when you're thinking about your careers. We also have students who continue research in PhD or research positions in companies, and there's some example places that people have gone on to do PhDs or other degrees listed there. So careers, I know, are very important to many of our students. They're very keen to know what they're doing next. The university has an excellent careers service that offers a lot of advice throughout the year, and we have an expert in informatics that drops into informatics once a week for drop-in sessions and whole sessions in the careers service. As an example of sort of the ongoing activity, it turns out that tomorrow we have a very large careers fair specializing in tech and data. So we have 40 companies coming to visit us. McEwen Hall is right next to our department, and our students will be able to go there and meet those employers. We also had a large careers fair in October that was not just for tech and data. So there were companies from all areas of industry and also government. And what I found interesting about that careers fair was that more than 90% of the employers were interested in hiring people from informatics. So regardless of what the company was or what sort of thing they were doing, they're interested in our graduates. So if you come here and say a little bit about the environment, the picture on the left is our main teaching building. So it contains some of our large lecture theatres, but also labs and small study spaces. So the large majority of this building is dedicated to informatics, and it's really our student space, and a lot of them make it their home. It's a very tall building, and so the views from it are amazing. It gives you this view over Edinburgh. It's a sort of large, brutal 1960s building, but it was recently completely rebuilt around the outside, and the inside has been replaced. So a lot of it feels like a brand new building. We take supporting our students very seriously. So one of the top floors of that building is dedicated to our teaching organization. So we've got a lot of administrative staff who make sure everything works smoothly. Amongst the professional staff, there's student advisors who make sure that you can settle into Edinburgh, you're okay, they can help you deal with any difficulties you may have. And we also find it's really important that you have good academic contacts. So we have what are called program directors, and you'll meet some of those in this session. And the program directors keep an eye on the overall degree, making sure it works, making sure it's up to date, and are there to make sure the program works well for you. And we also have people called cohort leads. So these are also academics like me and like the program directors, but they're focused on meeting smaller groups of you and making sure that you are settled in and that you get your questions answered about what it's like to be on the ground in Edinburgh, what your future career would be, and sort of look at your whole student experience. When I was a student, my student advisor said that they knew the students who would do well because they were the ones they saw going to lunch with other students and like really settling into the university. I think one of the main reasons to come to an excellent place like Edinburgh is that you join a really good cohort of students that will help you succeed. There'll be contacts for life and friends for life. And the university has a lot of student societies that can help that. So you don't have to spend your whole life in front of a computer. There are student societies for like rock climbing and magic and all sorts of hobbies, whatever you're interested in. But we also have a very vibrant tech society ecosystem if you're interested in taking a sort of computing further in your spare time. So Hoppers is a society to promote gender diversity in computing. And then CompSoc is the largest computing organization in Scotland. It's a computer science society. And within CompSoc, there are 10 different special interest groups. So whether you're interested in functional programming or competitive programming or AI or one of the other 10 areas that they're interested in, there are smaller groups you can meet. We also have societies that are in conjunction with physics and engineering on building really cool stuff. So we regularly win prizes on autonomous self-driving cars, Edinburgh Formula student. There are Hyperloop pods, which are these fast transport pods that shoot through tubes at high speeds. And there's a rocket society that builds actual large rockets that they sort of fire up and not yet into space, but that's their final goal.